Hi, I'm Melinda Rose.
And I'm Laura Marshall, and this is Light Matters for August 10th, 2011. In this week's 5 Minutes to Enlightenment, light is isolated on a photonic chip, gold nanoparticles detect the flu fast, an undergrad solves the problem of superluminal propagation and cloaking, and we bring you news from Newport and the NSF.
A new silicon-based optical waveguide isolates light to one-way travel on a photonic chip, enabling next-generation light-based computer technology. Diodes isolate electrical signals on chips by allowing current to travel in one direction but not the other. For the past 20 years, scientists have been pursuing the diode's photonic analog, called an optical isolator, which would do the same thing for light in a photonic circuit. A team from Caltech and UC San Diego designed a new type of optical waveguide, a 0.8 micron wide silicon device that channels and isolates light. Previous attempts to achieve optical isolation involved changing light's polarization by using a magnetic field, not something you want next to a computer, or nonlinear optical materials that change light's frequency rather than its polarization. That technique was problematic because silicon is a linear material and couldn't be used. With their new silicon waveguides, the researchers have become the first to isolate light with a linear material. The paper was published in the journal Science.
A new method that detects the flu by using antibody-coated gold nanoparticles scattered by laser light is both rapid and highly sensitive. Because biological molecules such as viruses are weak light scatterers, clustering a virus with gold nanoparticles, which scatter light very efficiently, causes the light to fluctuate in a predictable and measurable pattern. PCR, the current standard for diagnosing flu, can only be done in highly specialized labs and requires specially trained personnel to incubate the sample for 3 days, extract the DNA, and then amplify it many times. The entire process takes about a week and is too costly for routine testing. The alternative is a rapid test known as a lateral flow assay. While cost-effective, the test can't identify a specific viral strain. It also misses up to 50% of infections and is especially error-prone when working with small samples. By overcoming the weaknesses of existing tests, University of Georgia researchers hope to halt flu spread through more timely diagnosis and early treatment. They hope that an adaptation of the technique can be used to detect salmonella levels during poultry processing as well.
An undergrad at the University of St. Andrews has overcome a major hurdle in the development of invisibility cloaks, namely the ability to move while cloaked, by adding an optical device into the cloak's design that not only remains invisible itself, but also has the ability to slow light. Most invisibility cloaks work by bending light around the object you want to conceal. Bending it allows the light to engulf the object, much like water flowing over a rock in a riverbed, making it seem as if nothing is there. Light can only be accelerated to a speed faster than it would travel in space under certain conditions, and this restricts invisibility cloaks to essentially just one color or frequency. This means that the moment the cloaked subject moves, the scenery would distort, revealing the presence of an unseen object. The new optical device, known as an invisible sphere, would slow down all of the light that approaches a potential cloak, so the light rays would not need to be accelerated around the cloaked objects. It also works in all parts of the spectrum.
Newport Corp reported second quarter sales of $130 million and a profit of $14 million, and said sales for the quarter were the second highest in the company's history. The earnings were the first posted by Newport since it announced in July that it will acquire HiQ Technologies and Ophir Optronics. Newport completed its HiQ acquisition on July 29th. The deal with Ophir is expected to close in the fourth quarter of 2011.
The National Science Foundation recently announced a new program aimed at guiding promising research with commercial potential out of university labs. Here's what the NSF director had to say about the program.
NSF I-Code will create a new national network of scientists, engineers, innovators, business leaders, and entrepreneurs. It will help strengthen our national innovation ecosystem. Innovation Core Awards will help to strategically identify nascent science and engineering discoveries and will leverage NSF's investment in basic research for technology innovation.
The I-Core program will initially support up to 100 projects a year at $50,000 each for up to 6 months.
Our iPad 2 giveaway is still going strong. Anytime between now and September 30th, simply share a link to this or any edition of Light Matters with a friend or colleague, and make sure you copy lightmatters@photonics.com in the email you send, and you'll be entered into a drawing to win an iPad 2. A convenient link to share this video is located just below the Light Matters player on the Photonics.com homepage.
As always, send your questions or comments about our show to lightmatters@photonics.com. You can also follow Photonics Media on Facebook and Twitter.
Thanks for watching, and be sure to join us next week for another 5 Minutes to Enlightenment.